Good afternoon, students. This is Manoj Kumar, Assistant Professor in Kalpatra Institute of Technology. So I've been giving the lecture on some of the machine learning algorithms. So in today's concept, we will be going with a new concept, that is decision trees. Okay, so till now we have gone with machine learning algorithms like KNN and Bayes theorem. So now you go up with decision trees. So decision trees, it is one of the type of supervised learning algorithm. So supervised learning algorithm means, so input will be given, output also they will tell you what input will be given, that is X, and output also they will tell you what you should get, and that is Y, and how you program the input to get the output is called as supervised learning algorithm. Supervised means input as well as output will also be given. You have to write a set of instructions. So that is called as a supervised learning algorithm. So now you compare, it is one of the classification and prediction method. Okay, so you are classifying the data and you are predicting the result. For example, KNN, it is a supervised learning where you predicted whether, with an example, whether a tomato is a fruit or a vegetable or protein. Okay, so here then we come with another example. So in Bayes theorem, so Bayes theorem means what you will be doing if a student is income is low, middle, whether he is going to buy a computer or not. So that we have seen, we have predicted whether he will buy or not, and we will predict whether the tomato is a fruit or a vegetable, like that. Okay, so now you come for the supervised learning. Usually it represents a decision making process. So it will tell you to make a decision making, present the knowledge in the form of the tree. Okay, so useful for business strategy and process improvement. It is a powerful classifier. It will utilize a tree structure to model the relationship and among the futures and potential outcomes. So next you come further, what the tree will consist of. You all will be familiar with the trees. So trees will consist of root node, branches, and leaf node. Root node, branches, and leaf node. So what the root node and what it is seen, we are telling in detail here. So first will be the root node. Okay, next decision nodes. No choices to be made based on attributes of the job. Okay, decision is to be made. So decision will be decision nodes. Okay, so branches. So potential outcomes of the decision, what you see in yes, yes or no. That is, we are having two branches, terminal node, like that. Okay, so leaf node, that is the final. The decision nodes will be, terminal nodes will be the leaf nodes. Okay, so this is the example. All the terminal you see, terminal node. If your two terminals are formed from the decision node, terminal with the decision, this can be given as it is. Okay, so now you come for the decision trees. So should I accept a new job offer? Now you see, this is the root node. Salary at least 50,000. If yes, if no, if yes, commute more than 1 hour. Okay, that means you take 1 hour extra. Okay, so offer offers, if you commute more than 1 hour, yes, decline the offer. So your salary at least, it is yes or no. So if it is at least yes, the salary at least 50,000, yes, then you come. If you no, decline the offer. Okay, this is one of the example. So commute more than 1 hour. If yes, decline. If no, offers free coffee. If offers free coffee, yes, accept the offer. If not, decline 1 hour. Commute means wait. Okay, so commute means wait. So if it is wait for 1 hour means, if he offers free coffee, yes, that means accept 1 hour, no, decline offer. Okay, should I accept a new job offer? This is the concept of decision tree, whether to accept or decline. So see here, when you are going to accept, when salary at least 50,000, commute more than 1 hour, offers free coffee, commute more than 1 hour, yes, then you go with a decline. If no, wait for 1 hour, no, offers free coffee, accept the offer. Okay, this is the concept of decision trees. What are the benefits of decision trees? So rather than theory, you go with a programming program or example concept, there you will easily understand. What are the benefits? Interpretability, easy to interpret, understand and visualize, can handle both numerical and categorical data, simple to prepare and fit model. So what are its uses? Credit scoring model, applicant to be rejected or not. Marketing studies of customer behavior, diagnosis of medical conditions. Okay, so are built using recursive partitioning. Decision trees are built using heuristic called recursive. What is the meaning of recursive? Repeated. Okay, you have a function that calls itself is called recursive function, but in our terms, recursive means repeated. So repeated partitioning. So commonly known as divide and conquer method. So it is one of the divide and conquer method which splits the data into subset, which are then split repeatedly into smaller subsets and so on. A tree is divided into branches. Branches will divide it into leaves. So like that until the process stops when algorithm determines the data are homogeneous or stopping criteria has been met. So this is the condition on divide and conquer. So now you come further. So that is up to theory part of decision trees. So we can easily understand this particular concept using an example. Okay, so I will go with an example and take some say scenarios also. So now you come for the decision trees. So here you go with some of the examples. Okay, so what is the introduction given? So go given event, credit is the category. Okay, examples: who won given ball game, how should we file a given email, what word sense was intended for the given occurrence of word. So these are some of the examples that we will see in this. Use a decision tree to predict the category for new events. Predict what? The category. So categories means whether it is yes or no. That will be the categories for new events. Use training data to describe the decision trees. So come for the example. This is a very good example. Decision to be taken for the play tennis. Okay, understand the concept very well. So it is very important now. So very important now. So that we will see here. So first your outlook, whether you have to play tennis or not, that we will go with the outlook. And there you have gone with two outlooks. One is sunny, one is overcast, the other one is rainy. So these are the three outlooks you are having. If it is sunny means, okay, so sunny means where it is one of the overcast. Other one is overcast, the other one is rain. So if it is sunny, what is the humidity? Humidity, how much is the humidity? If it is sunny means, so it is so dark, so it is so bright sunny. Okay, so sun is so bright. For example, at 11 o'clock or 12 o'clock, you are having this one. So what is the humidity? So each internal node tester attribute. If humidity is high, then what is the humidity is high, then this is the result of playing tennis. Tumba shake, if you are having feeling to humidity means shake. So at that time if humidity is high, then playing tennis is no. If the humidity is normal, the play tennis is yes. So like this, yes and no will be the prediction what you are going to do it here. So next you come for the these examples. So you see here, so example of decision trees. So position, noun, verb, like this are the things you have to see. This are not very much important. So I will go with another example. So take this example. Okay. So if it is sunny, so apart from humidity, you can go for a wind also. If wind is too strong, you can't play tennis. So tennis court will be there. If you are moving at a very strong wind is there and it is blowing, then you can't play. If it is weak, You can play yes. When it is overcast, no. When it is rain, no. So this is when you have the sunny and wind is equal to weak. So what will be the result? When it is sunny and outlook is equal to sunny and wind is equal to weak. So what is the result? It is no. Okay. So now you come for the next concept. So now you go for the another decision trees. So overcast. Overcast means apart from temperature you are having. When wind is strong, no. When wind is weak, yes. So when it is raining, so even if it is rainy and if it is wind strong, you can't play. But if it is rainy and wind is so weak, just you are having some drizzling. So at that time you can go for the yes option. Okay. So now this is the concept. Okay, so XOR sunny, overcast and rain. So with wind, so each and everything. And depending on the wind, the decision tree is been framed. So decision tree will tell when it is strong, when it is sunny and wind is strong, yes. When it is sunny, when wind is weak, no. Overcast. With overcast will only have one option. With wind strong as no, wind weak as yes. Wind strong as no, when so what all the result you are having? When the wind is strong, the playing tennis will not work in overcast and rainy, but it will work in sunny. Similarly, when wind is weak, you will be having yes. But when it is sunny with no wind, so it will go with a no. Okay, so that is the concept. You can make the decision there. Okay, so now you have to see the decision here. So a decision tree represents disjunction of conjunction. So now you have to joining each and everything. So joining first you see sun is equal to outlook is equal to sunny and humidity is equal to normal. So what is the condition? Yes. So keep here your thing. So here it is yes. So I will tell you here it is. So outlook is equal to sunny and humidity is equal to normal. So it will be yes. So when outlook is equal to overcast, it will be is equal to yes. So outlook is equal to rain and wind is equal to weak. So you will be getting it as yes. So this is the decision we are going to make it here. Understood? So what is the decision you make? So you make it as yes. So when to consider decision tree? So when you are going to consider the decision tree, the instances describable by attribute value pair. So missing attribute values like medical diagnosis and credit risk, you are going to use the decision trees. So it is a theoretical part. So now you come for the decision tree algorithm. So top very important algorithm from exam point of view for machine learning and to understand the concept also. So it is ID3. So ID3 means this induction of decision tree. So tree they have made it as 3. Okay. So A is the best decision for the next node. Assign a decision for the node. For each value of A, create a new descendant. Descendant means coming down. That will be the descendant. So always if it is a root node or any other node, so you will be having a terminal nodes. So I have already told you root node. Below you can have decision nodes. From decision nodes you will be having terminal node. Terminal node is called as a leaf node. Okay, sort training examples to leaf node according to attribute value. If all training examples are classified, stop, else iterate. So this is the algorithm. So now you see here, you have to work some of the concepts here. Which attribute is best? So yeah, there is, so it is A1 is one attribute with 2 branches G and H with the leaf value as 21, 5, 8, 30. So A2 is equal to this one, low, medium, like that. Okay. So which attribute is best? Now you have to tell me. Okay. So you have to decide which attributes is best. So to understand that one, you have to go with a new concept called as entropy. So which attribute is best? So that we will go with a new concept, entropy. So first you see what is what all required. S is the sample of training examples. So training, I have come across the word training and testing, right? So you tell what is training? So training means if X input is also there and output is also there, so then we call it as training data. Testing data, if input is there and output is to be tested, so that we call it as a testing data. So okay, so training examples, in that output will be yes, some of the output will be no. So all the yes output is yes, that we call it as positive example P plus. Similarly, output is no, so that we consider it as negative examples. So if it is P plus and P minus, the entropy is calculated as minus P plus log to P plus minus P minus log to P minus. So that is the entropy example. Okay, so testing say examples, in that you are having two examples, positive examples and negative. So when you tell it is a positive, outcome is positive or yes or yes. Okay, if the output is yes, then we consider it as positive example. If output is negative, then we consider it as negative example. So that is the entropy concept. So entropy of S is equal to expected number of bits needed to encode of randomly drawn members. Okay, so in order, that is, we are taking this particular example, P plus positive examples log to positive examples minus negative examples log to negative examples. So that is the entropy concept. Okay, now you come for the very important concept. Now you have to decide whether, now you have to you are working for this one. Okay, for this one you are going with a new concepts like entropy. So which attribute is best? So in order to check which attribute is best, now you have to go with this example. Okay, so that is in information gain, S is equal to E. What is S and what is E, we will see. So S is the gain, E is the entropy. Okay, so S is the gain, E is the entropy. So gain of S comma A is expected reduction in entropy due to sorting S on attribute A. So this is the example we have taken. So entropy gain is equal to entropy of S minus. So this is the formula. Okay, suppose you have to calculate which attribute. So first you calculate entropy. So here also you see 29 plus 35 minus. Here also you see 29 plus 35 minus. So come for here. 29 plus 35 minus is, what is yes? 29. What is A? 35. So that will be calculated as, so minus 29 divided by 64. What is this 64? So it will be total of this one. 25 plus 94. So I will write it here. Kindly see how to calculate the information. 29 plus 35. So it is equal to 54. Sorry, 64. 9 plus 5, 14. 3, 2. 3 plus 2 plus 1, 64. Okay. So this is the, so you will get 64 like this. So minus 29 by 64 log to 29 by 64 minus 35 by 64 log to 35 by 64. What value you are getting? 0.99. Okay, so you are getting 0.99. So now you see. Now in that, okay, so what is the thing you have got? It is 0.99. You keep it. It's a total. Okay. Now you have to calculate for 21 plus 5 minus 8 plus 30 minus. Similarly, 18 plus 33 minus and 11 plus 2 minus. First you calculate for 21 plus and 5 minus. So 21 plus 5 minus. So 21 plus comma 5 minus is equal to, you will be getting 0.71. So how you will be doing? The same formula. Minus 21 divided by 27, like that you have to do. So similarly, entropy of 8 plus 30 minus will get you 0.74. Okay. So now you come for the last one. So gain of SA is equal to entropy of S. So how you take the entropy? So how you take the entropy? So that is using, now you calculated for all the four concepts you have calculated using the same entropy. Okay, so now you have to do, sorry, minus 26. What is this 26? So 26 is nothing but 21 plus. So how you get this 26? So 26 is equal to 21 plus 5, that is 26, divided by what is this 64? Can anybody can tell what is that 64? It is this one, entropy. Okay, so that is the concept. 26 divided by 64 star entropy of 21 plus 5 minus 38 by 64. What is this 38? So you have got this 38 from 8 plus 38. 8 plus 30 will give you 38 divided by entire. So the entire thing is 64. So entire thing is 64 star entropy. So what is the value you are getting? It is 0.27. Similarly, you do it for another attribute set. So first you are having 18 plus 30, 18 plus 33. So 18 plus 33 is equal to 51. Similarly, 11 plus 2 is equal to 13 divided by 64. You will be getting value 0.12. So which is the greater one? 0.27, and this one will go with 0.12. So which is the highest gain? So it is this one. Which attribute is best now? So now you have calculated that 39 plus 29 plus 35 minus is the best attribute. Okay, so now you come for the training examples. So very important concept now. So this is the example that you should consider for all the programs. Okay, so this concepts are used everywhere, so you have to understand. Okay, so there are, out of how many samples? 14 samples are there. So in that, how many are yes and how many are no, you have to see totally. Okay, so if it is sunny, temperature is hot and humidity is high, wind is weak, lateness no. So like that you have to work. So I will tell you the example. So now you see. So select the next attribute. So total samples. So out of 14, how many are yes, how many are no? So first you go with a yes. 1, 2, 3, 4, 5, 6, 7, 8, 9. Out of 14 samples, 9 are positive samples. That is P plus or 9 and P minus or 5. So 9 are plus, that is positive samples are 9 and negative samples are minus. So calculating the entropy E, that is 9 by 14 log to 9 by 14 minus 5 by 14 log to 5 by 14 will give you this value. Okay, so similarly you go with one with humidity, the other one with wind. Okay, so on humidity, okay, how many are high on yes? Okay, so that you have to go, that you have to see with this example. With positive, with the platen is positive and humidity is high. Humidity is high with positive yes. Okay, so here it is not coming. So here it is high with yes. So here it is high with yes. Next here no. Here it is high with yes. How many positive high? It is 3 positive high. So 3 positive. Similarly you go with 4 negative. Similarly when it is normal, 6 positive and 1 negative you calculate. So coming for the gain, so it is 0.940 minus, so 3 plus 4, 7 divided by 14 star this value minus 7 by 14 star this value. This is the gain. So you have to work on this. So then only you can understand this. So what is the gain for on both of humidity as well as wind? So humidity provides, now you see it is 0.15. This one is 0.04. So which one is best? Greater? 0.15. So that's why we tell humidity provides greater info and gain than wind. Humidity provides greater information gain than wind. Okay, so this one is finished. Select the next attribute. Okay, so outlook. So this you have got all this. So gain of outlook you come. So gain of S comma outlook is equal to, you have to follow the same principles of information gain. So just you have to go with all the values. So that is selecting the next attribute. So selecting the next attribute, information gain values for 4 attributes. Outlook is this one, humidity is 0.15, wind is equal to 0.4, 0.04, temperature. So various denotes the collection of training examples. Okay, so after selecting, now you see. So how many values you have with humidity? Everything you have given here, 0.24, 0.15, 0.04. So yes, now you go with the last one. When it is sunny, with humidity you are getting this one. With the temperature you are getting this. For wind is equal to 0.019. Okay, so what will be when it is sunny? So what you are getting? Humidity. So sunny with humidity, you are getting 0.97. Sunny with temperature, you are getting 0.57. So sunny with wind, you are getting 0.09. So you have to work on this, then only you can make. Okay, so final ID3 algorithm will tell you when outlook is sunny and humidity is high, no, that will go with D1, D2. So you have to tell where this classes will come. Okay, so similarly with sunny, with humidity normal, it will go with 8, 9, 11. Okay, so similarly when you are yes, you will get D3, 7, 12, 13. So these are the values. Okay, this is the, now you have to tell whether each and everything should come and like 1, 2, 3 is there here, 4 is there here, 5 is there here, there is 6 is there here, next 7, 8, 9, next 10 is there, 11, 12, 13, 14 is there. All the samples should come and sit in the ID3 algorithm. Next, converting. So now you see, seeing this, now you can define the decision rules. So it is a sub part. Okay, so if the outlook is, if outlook is sunny and humidity is equal to high, then plate NS is equal to no. If outlook is equal to sunny, humidity is normal, then plate NS is equal to yes. So outlook is overcast, then plate NS is equal to yes. Outlook is rain and wind is equal to strong, plate NS no. Outlook is rain and wind is equal to weak, plate NS is yes. So this is a converting the decision tree to the rules. So now you see continuous valued. So when temperature is 15, no. When the temperature are in between 19, 22 and 24, you will be going with the decision trees. Okay, so this is the concept on decision trees. So you have to work on finding the information gain. So then only you can tell which attribute is best and which one you can take it. Okay, so up to here will be the decision trees concept. I hope you will work. You have to work, then only you can understand the information gain. So gain index, Gini index, everything will be there. For now, you understand this basic concepts on decision trees. It is very well known, and you will be learning in machine learning also. So go through this particular concepts in detail, work on that and get the results. If you have any doubt, you can feel free to ask me. So kindly learn the concepts and become a machine learner. Okay, so I'll be ending. I hope you got people who have got the concept understood. I will be ending this particular session. Kindly go through, understand the concepts, be safe, stay secure. Bye.